Assalamu alaikum students. Unit number 4, algebraic expression and formulas, and it's exercise number 4.4 we have started in our last lesson, and now today we will solve more questions about this. And the 4.4 smart syllabus questions. In the question 1 we have seen the first part only, or we will see the 6th and 7th part today in this lesson. In the 6th and 7th part, see that rationalize the denominator again. In the first part it was very simple, 3 over 4 into square root 3. We'll have to rationalize this number, 3 over 4 into square root 3. But here the expressions are different, 2 over square root 5 minus square root of 3. And in the 7th part, square root 3 minus 1 over square root 3 plus 1. So you can see a sign of minus and positive in the denominator. Now to rationalize this expression, we will multiply it with its conjugate, that is square root 5 minus square root 3 will multiply with its conjugate, square root 5 plus square root of 3. We will multiply and divide it by square root 5 plus square root of 3. Let's start the question now. The 6th part of question 1 is rationalize the denominator of the denominator. 6th part, it is 2 over square root 5 minus square root of 3. 2 over square root 5 minus square root of 3. Now to rationalize this expression 2 over square root 5 minus square root 3, the procedure is 2 over square root 5 minus square root of 3, square root 5 minus square root 3. We will multiply and divide it by square root 5 plus square root of 3 divided by square root of 5 plus square root of 3. To rationalize this, we will multiply numerator with numerator and denominator with denominator. We have 2 into square root 5 plus square root of 3 divided by square root 5 minus square root 3 into square root 5 plus square root of 3. This is equal 2 into square root 5 plus square root 3, and in the denominator you can see a minus b into a plus b. A minus b into a plus b, we know it is equal to a square minus b square. Using this identity in the denominator, square root 5 whole square minus square root of 3 whole square. It becomes square cancel with the square root sign. This is 2 into square root 5 plus square root of 3 divided by, after removing that square root sign, we have 5 minus 3. This is equal to 2 into square root 5 plus square root of 3 over 5 minus 3 is equal to 2. 2 cancel with this 2, and the answer is square root of 5 plus square root of 3. So this is how we rationalize the denominator of the expressions given. Now the 7th part. In the 7th part, the given expression is square root of 3 minus 1 over square root of 3 plus 1. To rationalize this solution, square root of 3 minus 1 over square root of 3 plus 1. Square root 3 plus 1, its conjugate is square root of 3 minus 1. So multiplying and divided by square root of 3 minus 1 over square root of 3 minus 1. Multiply and divide by the conjugate. The conjugate of square root 3 plus 1 is square root 3 minus 1, multiplying and dividing by square root 3 minus 1. It is equal to, in the denominator we have square root 3, in the numerator square root 3 minus 1 whole square, whereas in the denominator square root 3 plus 1 into square root of 3 minus 1. Always in the denominator, as we did in chapter number 2, you will find a formula of what? A plus b into a minus b. A plus b into a minus b, again a plus b into a minus b is equal to a2 minus b power 2. Whereas in the numerator, see, square root 3 minus 1 whole square, it is something like a minus b whole square, because it is equal a square plus b square minus 2ab. So applying both the identities in the next step, we have a square plus b square, b is 1, minus 2 into a into b, divided by a plus b into a minus b equal square root 3 whole square minus 1 whole square. Square cancel with this square root sign, 1 square is 1. So in the next step, 3 plus 1 minus 2 into square root of 3, square cancel with this square root sign, 3 and 1 square is 1. Now adding the integers value, 3 plus 1, 4 minus 2 into square root 3, divided by 3 minus 1 is 2. Take 2 common in the numerator, we have 2 minus square root of 3 over 2. 2 in the numerator and denominator will cancel out, and the solved answer is 2 minus square root of 3. I hope you understand that they were the simple algebraic terms are used in it. Square root 3 minus 1 over square root 3 plus 1 were given. The conjugate of square root 3 plus 1 was square root 3 minus 1, so we multiply and divide it by square root 3 minus 1. While multiplying in the denominator, we get a complete square of square root 3 minus 1 whole square, whereas in the denominator, square root 3 plus 1 into square root 3 minus 1, it is something like a plus b or a minus b form, and in the numerator we have a minus b whole square form, a square plus b square minus 2ab applying here, and a plus b into a minus b is equal a square minus b square applying here. Square cancel with this square root sign, 3 minus 1 is 2, 3 plus 1 is 4, minus 2 into square root 3 over 2, taking 2 common in the numerator, into 2 minus square root 3 over 2, 2 cancel out, and the result is 2 minus square root of 3. Now the question number 2 and 2 is very simple. See it on the book. Question number 2, find the conjugate of x plus square root of y. In this question, to find the conjugate, we will simply change the sign. Question number 2 it is, find conjugate. Find conjugate of x plus square root y. The third part is, in the third part we have 2 plus square root 3. As we did in chapter number 2, to take the conjugate of a complex number will remain real parts same, where we change the sign of imaginary part, but here as it is about real numbers and rational numbers and surd, we will just simply change the sign of the surd to take its conjugate. It is third part. After that, seventh part is in your ALP syllabus, which is 7 minus square root of 6. Its conjugate will be 7 plus square root 6. So easy. And the only part for you is its eighth part. The eighth part is 9 plus square root of 2. Its conjugate will be 9 minus square root 2. So they are the very easiest and simple questions we have seen in this lecture today. And in the next lesson we will see remaining its part and try to complete this exercise. Thank you so much, students. I hope you understand that. Thank you.